Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to show you how to create simple methods, which allows us to split up our C# code into multiple code blocks. Now, simply put, a method is a block of code that's given a name so that you can call that name, you can execute that block of code from somewhere else. It's one of the basic building blocks for creating larger applications. We'll look at other building blocks a little bit later on, like classes and object-oriented programming a little bit later. Okay, so why would you ever want to split your code up into multiple methods? Actually, there's many reasons why. First of all, it's a good idea to never write the same code twice. Cut and paste is the sworn enemy of the software developer. It's a necessary evil at best, and at worst it will steal your soul, okay? You should stop yourself dead in your tracks whenever you realize that you need the same code you wrote up here in a second spot and think, whoa, wait a second, my tendency would be to copy and paste it, but I know better than that. I need to create a method instead and then call that method from both of those places. And so when you write a method and you call that method from each place where you need that functionality, you are limiting the amount of code that you need to change should a new requirement come up or you need to fix a bug or whatever the case might be. All right. So we've already worked with methods quite a few times already in this series. For example, we work with the main method every single time that we've written a new application. And that's just a very special kind of method that's triggered to execute when an application first starts up. We've also been calling or using methods that were written by Microsoft every single time that we called the write line method or the read line method or the write method or a bunch of others, okay? So let's just exercise this idea. Let's create some of our own methods and learn what we can do with methods and get a good feel for it. So I'm going to actually use a new technique to create a new project. There's this little button on the toolbar by default, unless you changed your buttons on your toolbar, that will allow you to create a new project. So there's a third way to do it. And make sure you're in the Visual C# templates. Make sure that you have selected the console application template. This time we're going to create a helper method project. So helper methods, and then click OK. First, I'll create some space beneath the static void main method. Notice that I'm not inside of static void main. I'm going to start by creating a method, kind of a brother or sister to the main method. Below it, inside of class program. Okay, and here we go. All right, now I'm going to call that method. Notice that IntelliSense did not pop up for me. I'll tell you why that is in a minute. Okay, so as you can see, the example is flawed. We get this red squiggly line. The error says an object reference is required for the non-static field method or property super secret formula. Okay, so I'll fix that issue in just a moment, but let me first explain what I intend for the code to do. So I want to create a custom method and then trigger, or rather call that method in my C# code. It's important to be careful where you write that code. As you see on my screen, as I pointed out and tried to make you aware of it right away, you should position the caret before the final two ending curly braces after the ending curly brace for our static void main. Now, I'm going to explain why that's important in an upcoming lesson, but for now just know that you'll get an error if you attempt to run this application. If you were to put that method we created anywhere else in code except inside the program class, okay? So make sure it's in the correct position. So let's deconstruct the code that you see here on my screen. On line number 18, let's start with the word private. It means that it can only be called from within this class. So it's a method, and it can be called, but it can only be called by other methods inside of this class. And that's opposed to public, which will allow it to be called from outside the class. Now, we're encroaching on a discussion of object-oriented programming. I really don't want to do that. That'll take us off in a whole other direction. For now, let's just stick with the keyword private as we create new helper methods. Then the next part, as you can see next to it, is the word string. We know that string is a data type. It's actually the return type for this method. So in other words, when I call this method, I can be guaranteed that it will return back to me a data type of string. All right, more about this in a moment. The next part is the name itself, which I named super secret formula. I could have called it anything. And in the next step, we're going to talk about how to execute this method by using the name that we just gave it. Now notice that I use a lowercase s in the word super, but every other word is capitalized. Again, this is a naming convention. We've seen this naming convention before. And a naming convention is simply just a way of writing code that gives a clue to everybody who follows that same naming convention what's going on here. This form of capitalization is called, do you remember? Camel case, right. And it's called camel case because it looks like it has humps like a camel, because every other word after the first word will be lowercase, every other word will have a capital letter. So capital S in secret, capital F in formula, right? And you use camel case to indicate that a method or a variable is private in scope. Again, I don't want to talk about what private and public mean. Just follow this whenever you name your helper methods that are private in scope, and you'll be in good shape, okay? So then, let's see, in line number, looks like 21, I use the keyword return. And this is the command to deliver the results back out to the method to call the code, to the code that actually called it. So in this case, we're returning back a literal string, hello world. Now, admittedly, this is a very simple example. Ideally, we would have really done some super secret formulas, some really cool stuff in this method. I wanted to keep it simple. But imagine having, a dozen lines, 2 dozen lines that perform some calculation. I have a friend I'm doing some work with that actually a client who is creating application for finance, and he has dozens and hundreds of methods that do different financial calculations. Okay, so that would be a good example of being able to encapsulate or put that logic in one spot and then be able to call it from a lot of different places. In this case, it's a little bit puny. We're only returning a string. Okay, enough apologies. So again, a method is just a code block with a name, and we're going to use that name, super secret formula, to tell that code block to execute. And since this method returns a string, we would expect one of the last lines of code to use the return keyword. In this case, the return keyword sends back the literal string, hello world, to the code that called this method by name. So back in the main event, we're going to call our new helper method. And when we do, we would expect to receive that string, hello world, and set that my value variable to the value hello world. That's returned by calling super secret formula, right? So as you can see, I'm declaring and initializing that value or that variable in one line of code. So line 14, let's see, line 14 then simply takes that value from the variable, my value, and passes it to the console.writeLine method. But as you can see, as I mentioned before, we're simply not finished because the red squiggly line prompts us to look at the error list. I guess we can bring that up by going here, like so, or I think we can just view it from the view menu, but we'll just find it this way. An object reference is required for the non-static field method or property helper method.program, that super secret formula. Okay, so what is the problem? Admittedly, that error message isn't very beginner friendly. Rather than explain the problem and the solution at this very moment, what I'm going to do is just go back to my code. Let's get rid of the error. Okay, and what I'll do is just add the keyword static here. All right. All right, so I'm going to explain the static keyword and its importance later in the series of lessons. I'm afraid it would be lost on you at this moment. We'll talk about classes and creating objects and creating instances versus static a little bit later. All right, so now if we start the application, we should see the phrase "Hello World" pop open in our console window. All right, the example again is super simple, but the concept is powerful. We can offload certain operations to other methods to organize and reuse our code or our logic. Furthermore, these helper methods can in turn call other helper methods and so on. Again, this example is simple, but the concept behind it is very powerful, and it's a crucial step towards building more complex applications. All right, so let's improve our helper method to make it a little bit more flexible and useful by allowing it to accept an input parameter. So when we create our methods, we can choose to accept 0 input parameters or 1 or many input parameters. And then in the body of the method, we would use the values that are passed into the input parameters to do something meaningful. In our case, again, we're going to keep it simple because this is a short video. We'll just accept a single input parameter, and then we'll use that to append to the end of that literal string "hello world." So it'll be real simple, and we'll just do this. In fact, I'm not even going to comment out this first one. I'm just going to go private static string super secret formula. And I'm going to create an input parameter called name. It'll be of type string. And here I'm going to return, oh, what is this? String.format hello. And then we've seen this string replacement code before. That shouldn't be new. Great. Now let's go up here to where we call super secret formula, and I'm going to pass in the literal string world. Okay, back here, exclamation mark there. Okay, so hopefully you can see what this is going to do. It accepts an input parameter of type name, and we're going to pass the string world into our super secret formula method so that it can be combined with the word hello and the exclamation mark and returned back and assigned to my value. Okay? Now it's a little convoluted, and again, this is a really absurd example, but I just wanted to show you how you can create an input or define an input parameter and then send data into the input parameter. All right. And admittedly, I got pretty fancy here with this replacement stuff and with the string.format and all that business. I could have simply done return hello plus name semicolon. All right, just a different way to do things. We'll look at that string.format a little bit later. All right, so let's go ahead and run the application, and we can see we get the results hello world again. All right, so furthermore, we can reuse this method anytime that we need this functionality. In this mundane example, I doubt we'd really ever find much benefit from it. But again, the concept is that we can send new inputs and reuse the functionality of that method throughout the application. So let's just approve this. Let's just go ahead and show that. Now, if I wanted to, in another part of my code, say, hello sunshine, now I don't have to rewrite all of this code that I wrote, just one line, but what if it was a dozen lines or 24 lines of code? I wouldn't need to repeat it. I can just call super secret formula, pass in a new input variable, an input parameter to change or modify what happens in the body of that method. Okay, great. All right, so now to push this idea forward, you can see that we have created two methods with exactly the same name. And Visual Studio didn't complain about that. We didn't get a compilation error. And furthermore, we were able to use both versions. So for example, now if I just wanted to use the first version, I would just remove the input parameter to see hello world, and then I can add sunshine back in to use the second version of the method. All right. And the reason is because when I added a second method with the same name, but a different method signature, I created an overloaded version of the method. So simply put, you can create multiple versions of the same method, each accepting a different number and or a different data type of parameters. As long as either the data type or the number of parameters is different, they can coexist. What you can't do is this. In this case, we will get an error when we try to call it. This call is ambiguous between the following methods. Why? Because it doesn't know which one is different. But if I were to do this instead, because the data type is different, it would be just fine. Okay, so that's what I mean by the method signature. The name, the number, and the data type of the input parameters have to be different in order to create overloaded versions of the same method. So as you can see, let's go here, console.writeLine. Now watch, open it up. There are 19 different overloaded versions of console.writeLine. And as I use the down arrow on my keyboard, you can see they take in different things, like it'll take a Boolean, which is another data type, true, false, the char, which as we know is just a single character. It'll take an array of chars, a decimal, which is a data type, which is like an integer, except it has values after the decimal place. Similar, double, similar with float. It'll take an int and a string and so on. All right, so there are all these different overloaded versions of the WriteLine method that we've been relying on up to this point. All right, so now you can remember just one method name and search through the different ways that it can be called to find the most convenient version of the method based on the data that you have available to you at the time, based on what the output you want is from that given method. So, and as you can see, the internal implementation of that method can be different in each case. Before I wrap up this lesson, we talked about methods that return a value. We define the data type of the return value in the method signature. So for example, we promise to return a string from our super secret formula method. But what if we don't want to return anything from the method? What if we just want to perform some action and that action doesn't need to send back a return value? Well, in that case, we would use the keyword void. When a method returns void, we're saying the method doesn't return anything. It does its work and quietly exits, and the code that calls it will just continue executing. So we have an example of this in the static void main. Main doesn't need to return anything because it's the entry point of the entire application. So typically, I create void methods when I want to delegate some responsibility and I expect it to work unless there's some problem, in which case I would expect an exception to be thrown. However, we're going to talk about that scenario much later in this series of lessons. For now, void means don't expect me to return anything to you. Okay, so the key takeaway in this lesson is the use of methods. And we're going to be using methods often in the coming videos for various purposes, and I just wanted to make sure that you have some exposure and explanation to them as we get started. As I said at the outset, a method is just one building block. We need to understand a little bit about classes as well, which you can think of as named blocks of code that are containers for our methods and some other stuff. And we'll talk about this at length in an upcoming lesson. We'll see you there. Thank you.